Hi, my name is Ron Paragoris. I'd like to introduce you to the CSI light cycle. In this demonstration, I'm going to show you our evaluation of our KISS electrical system. KISS is keep it simple, stupid. Albert Einstein said, make things as simple as possible, not simpler. Anyway, initially, my first KISS electrical system is nothing more than a Target 8-inch extension cord. These cost $6, under $6 for 3 of them. What I did is I seriesed 2 diodes, parallel diodes, and I put a fuse in there. The reason it's kind of ugly is because this thing does move around and I didn't want to stress it. It's kind of ugly, a lot of hardware. It's very difficult to crimp on diodes. Works fine though. Second iteration, much simpler. This guy I decided to solder. Anyway, 1 diode is soldered and there's a fuse in there. The reason there's a fuse in this iteration is I know somebody is going to plug the plug into a 115 volt outlet. Right now we have ground is being used as negative for DC and the neutral is being used as positive. And normally if you plug this into a 115 volt outlet, if the outlet is wired correctly, there will be no problem. It's just shorten out these 2 connections. And when you pedal, when the motor's shorted, it'll just be very hard to turn. It's not going to damage anything. At an electrical box of 115 volts in a house, the neutral and ground are connected in the box. That's all that would happen. But it happens all the time that sometimes the polarity is reversed, where somebody is throwing positive onto that lead. If that happens, if all of a sudden you plug it into a reversed polarity, what you're going to be doing is sending 115 volts to our poor 12 volt DC motor. Good chance it's going to damage it. Anyway, I now have a 10 amp fuse in series with it. At least it will protect the 15 amp wire and hopefully protect the motor from getting damaged. It is soldered in place, so if somebody burns it out, you're going to have to resolder it. I don't feel bad. The diode may blow up also, I don't know. Anyway, there's a good chance that if it does happen, at least you're not going to catch fire to anything. It will blow the fuse. Anyway, I'm going to give you a demonstration of it right now. As far as an amp meter, there is no amp meter, but I'm going to demonstrate how a voltmeter can be used to show you how much you're charging the battery. So here we go. We're going to plug in series, our inexpensive KISS electrical system to our inexpensive, flexible Target plug going into our $3.27 Home Depot plug connected to our battery. You could see right now this could be any sort of voltmeter. It doesn't have to be a voltmeter like this. You could have one that plugs into a cigarette lighter. I just happen to have my leads clipped to the positive and negative of the battery. We happen to have a clip-on amp meter over here just to show you how we're doing. I'm going to jump on the light cycle. We're going to generate some electricity. Right now we're at 12.11 volts. By the way, here's a little chart of battery voltage. If you let the battery sit for 2 hours, if it's 12.2, we're 50%. If we're 12.5, it's 75%. And if it's 12.8, it's 100%. This battery is not doing too good. It needs to be charged. What I'm going to do initially is I'm going to throw 1/10 of a volt over 12.11. We're going to go to 12.21, and you'll see on the amp meter how we're doing. So I'm pedaling right now. So 12.21, we're just about an amp. You know, we're putting an amp in there. If I go 2 amps, without even looking at it, this is what I feel comfortable with. It's about 25 watts. If you look at the amp meter, it's about 2. All I know, if I stop pedaling, I see the voltage down. And if all of a sudden I start pedaling, the voltage is up. If you just pedal as hard as you know, if you pedal too hard, you're going to start feeling bad. I don't even think we need an amp meter. Anyway, this is the KISS electrical system. I think anybody with a little bit of experience could figure out how to charge batteries. Thanks for watching the video.